In today's tutorial on industrial instrumentation, we will talk about flow measurement part 6. The topics that we'll discuss here are ultrasonic flow measurement and its two types, transit time flow measurement and Doppler effect flow measurement. The ultrasonic flow meter is a type of flow meter that measures the velocity of a fluid with ultrasound to calculate the volume flow rate. Using ultrasonic transducers, the flow meter can measure the average velocity along the path of an emitted beam of ultrasound by averaging the difference in measured transit time between the pulses of ultrasound propagating into and against the direction of the flow, or by measuring the frequency shift from the Doppler effect. Ultrasonic flow meters utilize sound waves to measure the velocity of a fluid from which the volumetric flow rate can be calculated. Unlike most flow meters, ultrasonic meters do not include any moving part and thus are more reliable, accurate, and provide maintenance-free operation. Since ultrasonic signals can also penetrate solid materials, the transducers can be mounted on the outside of the pipe, offering completely non-invasive measurement, eliminating chemical compatibility issues, pressure restrictions, and pressure loss. Ultrasonic flow meters are affected by the acoustic properties of the fluid and can be impacted by temperature, density, viscosity, and suspended particulates depending on the exact flow meter. The Doppler effect is numerically given as del F equal to 2V F cos theta by C. The fluid flow rate Q in a pipe of cross-section of area A is given as Q equal to A into V equal to AC del F by 2F cos theta. Broadly classifying, there are two types of ultrasonic flow meters. They are the transit time flow meter and the Doppler shift flow meter. The first type of ultrasonic flow meter is the transit time flow meter. In the transit time flow meter, the flow meter measures the travel time of two sound waves. One wave travels the same direction as the flow, while the other travels in the opposite direction of the flow. At zero flow, sensors receive both the waves at the same time, that is without transit time delay. As the fluid moves, it takes an increasingly longer time for the downstream wave to reach the upstream sensor. This measured transit time difference is directly proportional to the flow velocity and therefore to flow volume. Transit time flow meters require the fluid to be free from suspended solids or gas bubbles and in a closed and full piping system. With zero flow velocity V, the transit time T0 of the pulse from the transmitter to the receiver with Vs sound velocity is given by T0 equal to L by Vs. But with the velocity V, the transit time T0 becomes small t equal to L by Vs plus V equal to L into Vs minus V by Vs squared minus V squared. Thus we get del T equal to T2 minus T1, which is equal to L by Vs minus V minus L by Vs plus V equal to 2LV by Vs squared, since V is very small compared to Vs. The second type ultrasonic flow meter is the Doppler shift flow meter. Doppler shift flow meter operates on the principle that the wavelength of an approaching sound source is shorter than the wavelength of that same source as it is moving away. A transducer emits a sound wave which reflects off entrained particles or bubbles back to the transducer. The measured difference in the wavelength of the transmitted signal versus the reflected signal is proportional to the process velocity. Doppler flow meters are used for slurries, liquids with bubbles, or gases with sound reflecting particles. They can also be adapted for use in open channels by integrating with level transmitters. The velocity of the fluid is given by V equal to del F Ct by 2 f naught cos theta equal to del fk, as the other factors are constant, where del f is the difference between the transmitted and the received frequencies, ct is the velocity of the sound in transducer, f0 is the frequency of the transmission. Theta is the angle of transmitter and the receiver crystals with respect to the Piper axis, and k is a constant. Few advantages of the ultrasonic flow meter are: it has no pressure loss, it has the capacity for detection from outside the pipe, it is corrosion resistant, it has no moving parts, and therefore there is no drift in the measurement. Few limitations are: long pipe section is required for good reading, solid suspensions cause inaccuracies, air bubble in the flow hinders measurement, and too much turbulence in a flow causes inaccuracies. For more detailed information, the viewers can refer to the following links and references. Thank you.